हाँ जी,
गुड
लेट्स
मॉर्निंग मैम।
स्टार्ट। आज हमने सीपीएम मॉडल करना है। कल हमने पर्ट मॉडल कर लिया था। सीपीएम जो मॉडल है वो क्रिटिकल पाथ मॉडल है।
मैम
अब
सैटरडे लगी थी क्लास?
हाँ, सैटरडे को क्लास लगी थी, उसमें पर्ट मॉडल किया था। आपको उसकी रिकॉर्डिंग मिल जाएगी।
ठीक है मैम।
ठीक है। प्रोजेक्ट मैनेजमेंट चैप्टर चल रहा है हमारा। सबसे पहले ये प्रोजेक्ट मैनेजमेंट के मीनिंग बताएंगे, देन आपको आगे पढ़ाते हैं।
मैम ये अभी ऑपरेशनल मैनेजमेंट ही चल रहा है ना?
हाँ जी, हाँ जी, अभी ऑपरेशन मैनेजमेंट चल रहा
ठीक है।
activity interrelated with each other but in a logical sequence. The logical sequence is known as precedence relationship. So precedence relationship means, for example, if you take one particular project, it has 5 activities. For example, A, B, C, D and E. So after completing A, that is the first task, first activity is A. After completing A, then you will move on to B. Okay, so here, so after completing A only, you can able to move on to B. Okay, here we have a relationship between A and B. That relationship is called precedence relationship. So this we'll see with the example problem. A project is represented in the form of a network for the purpose of analytical treatment to get solution for scheduling and controlling its activity. A project.
ठीक है। प्रोजेक्ट मैनेजमेंट क्या होता है? हमने अपने प्रोजेक्ट को ऐसे मैनेज करना है कि हर एक्टिविटी हो जाए, टाइमली हो जाए, और उससे हमें जो रिजल्ट आए वो ऑप्टिमम रिजल्ट्स आए। ठीक है। यानी कि हमें अपनी एक्टिविटी को शेड्यूलिंग करनी है कि 1 के बाद 2 करनी है या 1 के बाद 3 एक्टिविटी परफॉर्म करनी है, 3 के बाद फोर्थ एक्टिविटी करनी है या फिफ्थ एक्टिविटी करनी है, या दोनों को साथ में करना है। यानी कि हम प्रोजेक्ट मैनेजमेंट में ये करेंगे कि अपने प्रोजेक्ट को कंप्लीट करने के लिए हमें कितनी एक्टिविटी परफॉर्म
Represent in a
करनी पा रही है।
network form in order to prepare or find the solution for.
ठीक है, कितनी एक्टिविटी परफॉर्म पड़ रही है वो देखेंगे। देन उस एक्टिविटी को परफॉर्म करते करते हम नेटवर्क जो बना रहे हैं, इनकी फर्स्ट के बाद जो एक्टिविटी आ रही है वो चेक करेंगे कि कौन सी करनी है, ताकि हमारा टाइम कम लगे और हमारी जो रिजल्ट्स हैं वो ऑप्टिमम आए।
For scheduling and controlling its activity, so we need to apply network method. So these are the basic concept of project management. In this project management, it has two basic techniques. First one is CPM and second one is PERT. CPM means critical path method and the second technique is project evaluation and review technique. Next one is phases of project management. So it has 3 phases. The first one is planning, second one scheduling, and third one controlling. So under planning, dividing the project into distinct activities. And second one, estimating the time requirement for each activity. So how much time is required to complete each and every activity, that we have to decide in advance. Next one.
Has it happened to you that a shopping platform seemed to know exactly what you needed even before you did? Well, all thanks to data science. By analyzing your browsing and purchasing habits, e-commerce platforms like Amazon create personalized product recommendations.
Establishing precedence relationship. The precedence relationship is very important. So we need to establish the precedence relationship among the activity. This will.
ठीक है, ये नेटवर्क का फॉर्म है। ये नेटवर्क्स
In
होते हैं।
order to complete the first activity, we need to have 2 nodes, 1 and 2. This one is 8 and 9. So these, that is controlling. So these are the 3 phases of project management. Now let us see the guidelines for network construction. Here
हाँ जी, ये
that is
गाइडलाइंस
controlling.
हैं कि
So these are
नेटवर्क
the
जो
three
बनाना है वो
phases
कैसे
of
बनाना है.
project management. Now let us see the guidelines for network construction. Here we have one model network construction. With the help of this model, we are going to learn guidelines for network construction. See the first guideline, the starting event and ending event of an activity are called tail event and head event respectively. Look at the module. This is the network construction. Here we have a different activities. So these are the things are called node. Node 1, node 2, node 3, 4, 5, 6, 7, 8 and 9. So these are the activities A, B, C, D, E, F, G, H. The last activity is I. So these are the different activities in the network construction. Okay, so the first point is, the first guideline is, the starting event and ending event of an activity are called tail event and head event. The first one is called tail. The completing event, the completion event is called head event. So in order to complete the first activity, we need to have two nodes, 1 and 2. This one is called tail, this one is called head. Second one, the network should have a unique starting node, that is tail event. For each and every activities, we need to have a unique tail event. Tail event means the starting event is called tail event. The network should have a unique completion node, that is head event. See, for activity A, this is a tail event, this one is head event. For each and every activities, it has tail event and head event. Tail event and head event. Tail event and head event. The starting node is called tail, the ending node is called head. Next, no activity should be represented by more than one arc. Arc means activity in the network. See, for each activity, it has two nodes. There will be no activity should be represented by more than one activity. So for each thing, we'll have only one activity. Next one, no two activities should have the same starting node and the same ending node. Look at the network. There will be no two activities which start in the same node and which ends in the same node. For each and every activity, there will be a unique starting point and unique end point. So there will be no two activity which start in the same place which ends in the same place. And the last one, dummy activity is an imaginary activity indicating precedence relationship only. So duration of a dummy activity is 0. Look at the network. After completing activity A, then only we'll move on to B, C, D and F. Okay, in the same way, after completing 4, 5, then only we'll move on to 6. So here we have a precedence relationship, that is 4, 5 is a precedent relationship for the sixth activity. So we have a dummy activity. So for dummy activity, dummy imaginary activity, there will be no duration for this. So this imaginary activity indicates precedence relationship only. So there will be no duration for this dummy activity. The duration is 0 only. Let us see the
ठीक है, जो हमने पीछे देखा दैट इज डमी एक्टिविटी. जब भी डमी एक्टिविटी को रिप्रेजेंट करना है तो ऐसे वाली लाइन से रिप्रेजेंट करना है. ठीक है, जो डायरेक्ट एक्टिविटी है उनको स्ट्रेट लाइन से रिप्रेजेंट करना है और जो डमी होगी उसको डॉटेड लाइन से. ठीक है, और इनका जो ड्यूरेशन होएगा, लाइक इनकी ड्यूरेशन तो हमें पता चलेगी दी होगी, लेकिन डमी की कोई ड्यूरेशन नहीं दी होती. तो डमी की ड्यूरेशन जो है वो यहाँ पे लिखेंगे हम 0 रहेगी डमी की ड्यूरेशन. ठीक है, यानी कि टाइम पीरियड.
This imaginary activity indicates precedence relationship only. So there will be no duration for this dummy activity. The duration is 0 only. Let us see the problem. Consider the details of a project as shown in the table. Some information is given regarding the project. So these are the different activities. These are the informations regarding immediate predecessors. That is, after completing this activity only, you can able to start this activity. And after completing this, you can able to start this activity. And this one is duration. For each activity, these are the duration. So these are the three informations are given. Activity, immediate predecessors and durations. Now, with this information, they ask you to construct the CPM network. CPM means critical path method. And second one, determine the critical path and project completion time. And the last one is compute total floats and free floats for non-critical activity. So these are the questions they have asked from these informations. First, let us see how to construct the CPM network. Look at the problem. See the first activity. For A, B, C. So these are the three activities without any immediate predecessors. So there will be no predecessors. Directly you can start three activities A, B and C. Node 1. For each activity we need to have two nodes. Okay, so first activity is A without any predecessors. For activity A. And then activity B also no predecessors. So directly you can start from here. Activity B. Then activity C also no predecessors. So directly you can start activity C. So activity A, activity B, activity C. Now write the duration for each activity. For A, 2 months. For B, 5 months. For C, 4 months. A, 2 months. B, 5 months. C, 4 months. We have started three activities. A, B, C. A, B, C. Next one, that is D. Okay, but here predecessor information is given, that is B is a immediate predecessor for D, which means after completing B only you can able to start D. Okay, in the same way one more B also is there, so B is immediate predecessor for G also, so which means after completing B you can start D as well as G. B is the immediate predecessor for two activities, that is D and G. These are the two activities which can start after completing B. Before you draw activity D, just check whether D ends individually or it ends with any other activity. For that you have to verify immediate predecessors. Look at this activity here. CD. It's an immediate predecessor for H and CD is immediate predecessor for I, which means C and D both the activities ends in a same place. So now you have to start from B and ends with C. B ends here now. So now you have to start D. D starts from here and ends with C. C and D both the activities are ends in a same place. D. Duration, look at the duration, 5 months. So far we have done network for activity A, B, C and D. Now you have to draw E. So before you draw the network, just see whether the particular activity is an immediate predecessor for any other activity, so that you can draw a network individually or you can find the exact direction. Yes, E is there. So E is an immediate predecessor for J. But it is an independent activity. It ends separately. Okay, so now you can start E. But where E starts? Where A ends. So A ends here. Here you can start E.
Starting from zero in JavaScript can be harsh. Zero experience.
Node number 5. E. Duration 7 months. E is over. Then move on to next activity, F. Just check F is an immediate predecessor for any other activity. Yes. So F is an immediate predecessor for K as well as for L. F is not an independent activity. Why? Because it ends with some other activities. In single node, F, G and H ends in single node. But F starts where A ends. A ends here. It starts from here. F. Duration 3. At the same time G. So G also ends in same node. H also ends in same node, but where it starts? G starts where B ends. B ends here, so it starts from here and ends with same node. And look at the next activity, H. So H also ends in same node, but it starts where C and D ends. C, D ends here, so it starts from here and ends in same node. So this one is G and this one is H. So these are the three activities. This activity starts where A ends, this activity starts where B ends, and this activity starts where C, D ends. These are the three activities ends in same node. Now write the duration. For G, 3, for H, 6 months. Node number 6. So we have done F, G and H. Now move on to the next activity, I. So just check whether I is an immediate predecessor for any other activity. Yes, I is an immediate predecessor for activity M, but it is an independent activity. It starts alone. But where I starts? Where CD ends, I starts. So CD ends here and I starts from here. Node number 7. I, look at the duration, 2 months. I is over, then J. Look at the immediate predecessor. Yes, J is there. So J, K ends together. So J is the immediate predecessor for activity N. It is not an independent activity. It is a dependent activity. Why? Because it ends with some other activity. So J starts where E ends. E ends here. So J starts from here. Duration 5 months. Over. Then K. So K is the immediate predecessor for activity N, but it ends with J. So now only we have drawn J, no. Node number 8. So J ends here, K also ends here, but K starts from where? K starts where F, G, H ends. F, G, H ends here. So K starts from here and ends with J. Duration for K, duration 4 months. Now move on to next activity, L. Just check whether L is the immediate predecessor for any other activity. No. L is an independent activity, but it starts where F, G, H ends. F, G, H ends here. L starts from here but ends individually. Node number 9. 3. Next one, M. So M also independent activity. Why? Because it's not an immediate predecessor for any other activity. So it starts where I ends. So I ends here. It starts from here and end in the last node. That is M. Duration 12 months. And the last one, N. So N also is not an immediate predecessor for any other activity. It is a last activity and it starts where JK ends. JK ends here. It starts from here and ends here. 9 is the last node. Duration 8 months. Look at these three activities, L, M, N. So these are the activities which is not immediate predecessor for any other activities. So these are the activities called as ending activity. So 3 activities ends in same node. This is the procedure to draw CPM network. First one is over. That is construct the CPM network is over. Now move on to next calculation. That is determine the critical path and project completion time. Now let me explain what is the meaning of critical path. See, critical path means the critical path of the project network is the longest path in the network. So this can be identified by simply listing out all the possible paths from the starting node of the project to the ending node of the project, and then selecting the path with the maximum sum of activities on that path. See, look at the network. Here node 1 is a starting node and 9th node is a ending node. Okay, so just find out the paths which starts from 1 to 9. Node 1 to 3, then 3 to 6, then 6 to 9. Starts from 1 and ends with 9. Okay, so this is one of the possible path. And look at the next one. From 1 to 4, 4 to 6 and 6 to 9, also one of the possible path. And next one, 1 to 4, 4 to 7 and 7 to 9. Then 1 to 2, 2 to 6, 6 to 9. Then 1 to 2, 2 to 6, 6 to 8 and then 9. Then 1 to 2, 2 to 5, 5 to 8 and 8 to 9. So these are the various possibilities which starts from 1 to ends with 9. So now you have to find out which path is the maximum duration. So which path is a critical path. So in order to find out the exact critical path, we have to follow certain rule. There are two phases in order to find out the critical path. First one is determine earliest start time for all the nodes. So this is called as forward pass. And the next one is determine latest completion time of all the nodes. This is called as backward pass. So these are the two phases. We need to find these two things in order to find out the critical path. For each node, we need to have two squares, upper square, lower square. Okay, so these two squares is very important for each and every nodes. The lower square stands for earliest start time and the upper square stands for latest completion time. So you need to find earliest start time and latest completion time for each and every nodes. For that only I have drawn a blue color square, upper square and lower square. Now let us see how to calculate earliest start time for each and every node. Look at the formula to determine earliest start time. So earliest start time of J. J stands for ending activity. I stands for starting activity. So maximum of earliest start time of ith activity plus duration. So you will be getting earliest start time of ending activity. So now I am going to show you how to apply this formula. Okay, so earliest start time of first node is always 0. Okay, now you have to find out the earliest start time for node 2. Okay, look at the calculation. Earliest start time of J is equal to maximum of I, that is earliest start I plus duration. Okay, so for node 1, earliest start time is always 0. Now you have to find out the node 2. For node 2, earliest start of I means for node 2, which one is starting node? 1 is a starting node. Starting node time is 0. Earliest start time is 0. So earliest start time of starting node plus duration. 0 plus duration 2. For activity A, duration is 2. 2. Answer 2. So earliest start time of node 2 is 2. Okay, in the same way, for node 3, same thing. Earliest start time of starting node plus duration. So for 3 is a ending node. Which one is starting node? 1 is a starting node. Starting
I have to finish this paper. I'm swamped. No one told me college would be so damn.
node earliest time is 0. 0 plus duration 5. So 5 is the earliest start time for node 3. Now for node 4, here we have two options. One is starts from 1 to 4 and 3 to 4. So two options are there now. Here you have to find out the maximum value. So for the forward pass, we have to find the maximum value. So previous one starting time is 5 plus duration 5, total 10. Look at the other option. The starting node is 1 node. So starting time is 0 plus 4. 4. So which one is maximum value? 10 is the maximum value. So we have to put only maximum value. Next, fifth one. So fifth one, for node 5, only one options are there. That is the previous one starting time 2 plus duration 7. So 9. Look at the sixth node. Here we have 3 options. First one is 2 to 6 and 3 to 6 and last one 4 to 6. So here you need to pick the maximum value. Look at the first option 2 to 6. Here starting time is 2 plus 3, 5. And second option starting time is 5 now. 5 plus 3, 8. Third option 4 to 6. Timing 10 plus 6. So which one is maximum value? This one is a maximum value. So put 16. So we need to find the maximum value. Look at the seventh node. Here we have only one option. The starting time is 10 plus 2, 12. The next node is 8. So here we have two options. One is 5 to 8. Another one is 6 to 8. Now you have to pick the maximum value. So 9 plus 5, 14. 16 plus 4, 20. So which one is maximum? 20 is the maximum. Then look at the last node. Here we have three options. One is 8 to 9, 6 to 9 and 7 to 9. Here you have to pick the maximum value. 20 plus 8, 28. 16 plus 3, 19. 12 plus 12, 24. So which one is maximum? 28 is the maximum. That is 20 plus 8, 28. We have got earliest start time for each and every activity according to this formula. Earliest start time of ending activity is equal to maximum of earliest start time of earliest one, that is starting node plus duration. Now we need to find the latest completion time for each and every node. Okay, for this calculation you have to start from the ending node. This type of calculation is called as backward pass. For the last node, ninth node, latest completion time is always is equal to earliest start time, that is 28. Look at the formula. Latest completion time of I represents starting node, is equal to minimum of latest completion time of j minus duration. In the previous we have added the duration. No, here we need to subtract the duration from the latest completion time of jth activity. J represent ending activity. So we have calculated latest completion time for ninth node. Now calculate latest completion time for 8th node. For node 8, latest completion of ending activity. J stands for ending activity. No. So ending activity is 9 minus duration of 8, 9. So 8, 9 duration is 8. Ending activity latest completion time is 28. So latest completion time of 9th node is 28 minus duration of 8 and 9. 8 and 9 duration is 8. Answer 20. In the same way, for node 7, latest completion time of 9th node is 28 minus duration 12. You will be getting 16.
जब हमने बैक जाना है तो हम 28 से जो ये ड्यूरेशन टाइम है वो माइनस करते जाएंगे. यहाँ से इधर आए तो प्लस करते हुए आए हैं सारे, ठीक है. ये इसको 4 से प्लस किया, 10 आ गया, ये सब प्लस करते हुए आए हैं. लेकिन जब हम यहाँ से 28 से बैक जाएंगे तो सबको माइनस करते हुए जाएंगे. क्लियर है?
B, then ending activity is 3. Okay, so for node 3, 15 minus 7, 8, 16 minus 3, 13. So which one is least? 8 is the least value. Move on to the last one, that is node number 1. For node 1, we have three options. One is 2 to 1, 3 to 1 and 4 to 1. So here you have to find out the minimum value. Just see the first one. 8 minus 2, 6. 5 minus 5, 0. 10 minus 4, 6. So which one is minimum value? 0 is the minimum value. So now we have calculated latest completion time of each and every node according to this formula. Now we need to find the critical path. So in order to find the critical path, we have three conditions. Look at the conditions for critical path. So the first condition is earliest start time of starting activity is equal to latest completion time of starting activity. So both must be equal. In the same way, for ending activity also, earliest start time is equal to latest completion time. This is the second condition. And third condition is earliest start time of ending activity minus earliest start time of starting activity is equal to latest completion of ending activity minus latest completion time of starting activity is equal to duration. So these are the three conditions to be satisfied in order to consider a particular activity as critical path. Look at the first node. Earliest start time is 0 and latest completion time also 0. So first condition is satisfied. Look at the second condition. Earliest start time of ending activity is equal to latest completion of ending activity must be equal. So here
ठीक है, वो
starting
बोल रहे हैं कि स्टार्टिंग की एक्टिविटी भी बराबर होनी चाहिए और एंडिंग की भी. हमारी स्टार्टिंग भी बराबर है 0 0 और एंड भी बराबर है 28
node is 1, ending node is 3. Look at this path. The ending activity is 3. Node 3 represent ending activity. So ending activity earliest start time is 5 and ending activity latest completion time also 5. So condition number 2 also satisfied. And look at condition number 3. Earliest start time of ending activity. That is the ending activity is 5. Earliest start time is 5 and earliest start time of starting activity. Starting activity is 0. So 5 minus 0 is equal to duration. That is 5. Okay, in the same way, latest completion time of ending activity. So for the first, for activity B, then ending activity is 3. Okay, so for node 3, latest completion time is 5. Latest completion time of ending activity 5 minus latest completion time of starting node. Starting node is 1 no. So latest completion time 0. 5 minus 0 is equal to 5. That is LC minus, that is latest completion time of J minus latest completion time of I is equal to duration. So third condition also satisfied. Then it will be a critical path. So put one double line to identify, to highlight the critical path. Just darken the line for identification. So 1, 3 is a critical path. Okay, so both starting time and completion time must be equal. Then move on to the next one. From 3 to 4, here 10 10. This is also a critical path. Then
ठीक है.
next,
जो इक्वल होंगे, जिनका स्टार्टिंग और कंप्लीशन टाइम एक जैसा है, वो क्या बनाएंगे? वो क्रिटिकल पाथ बनाएंगे. लाइक 0 0 इसलिए 1 क्रिटिकल पाथ बना रहा है. 1 से 5 5 वो क्रिटिकल पाथ. 5 5 से 10 10 यानी कि फोर्थ वो क्रिटिकल बना रहा है. फोर्थ से जाएगा 6 पे, दैट इज 16 16. वो भी दोनों इक्वल हैं, इसलिए वो भी क्रिटिकल पार्ट का पाथ बनेगी.
here from 4 to 6. Here also we have starting time and completion time is equal. So it is also a critical path. Then from 6 to 8, 20 20 equal. So this is also a critical path. Then 8 to 9, 28 and 28 equal. So this is also a critical path. So critical path means longest path is called critical path. So each and then 6 to 8 activity K, then 8 to 9 activity N. So this is critical path. Now we have to find out the total duration of this critical path. Duration is 5 plus
सबकी ड्यूरेशंस
5
को ऐड कर देंगे तो
plus
टोटल ड्यूरेशन आ
6
जाएगी.
plus so critical path duration is 28. This is a critical path, that is B to D, D to H, H to K and K to N is a critical path, and project completion time is 28 months. Look at the problem. So far we have done two things. The first one is construct the CPM network is over, and second one determine the critical path and project completion time. This is also over. The last one is compute total.
Now हम सिर्फ total float और free float निकालें, ठीक है?
Total floats, and for activity A duration is 2. For activity A duration 2, for B 5, for C 4, for D 5. So this is the duration for all the activities from A to
सभी
N.
activity की duration
Now
लिख
we
लेनी
need to
है.
find the total float with the help of the formula. This is the formula for total float. That is latest completion time of ending activity minus earliest start of starting activity minus duration. For activity A, see node 1 to 2. 1 to 2. So latest completion of ending activity. Ending activity is 2. See, the lower square represent earliest start, the upper square represent latest completion. This is common for all the nodes. Okay, so for total float, latest completion time of ending activity. For activity A, node 1 is a starting node and 2 is the ending node. So just apply the formula. Latest completion time of 2, that is ending node is 2. No. So latest completion time is for node 2, latest completion time 8. 8 minus earliest start of starting node. Starting node is 1 no. So for node 1, earliest start time. So this one is earliest start and this one is latest completion. So earliest start time is 0. 0 minus duration of this particular activity 1 and 2. So what is the duration for 1 and 2? 2. 2. So answer 8 minus 0, 8. 8 minus 2, 6. Total float for activity A is
total
6.
float कैसे निकालना
For
पता चल
activity
गया?
B,
ऐसे ही सभी
1 to
activities का निकाल लेंगे.
3. See, 16 minus starting node minus duration.
Now free
For
float निकाल
activity
दिया.
A,
Free float
node
कैसे
1,
निकालेंगे?
2. So node 1 is a starting activity and node 2 is the ending activity. Earliest start time of ending activity. So ending node earliest start time is 2 and earliest start time of starting activity is 0. So 2 minus 0. So activity A duration is 2 minus 2. You will be getting 0. For activity A, free float is 0. For activity B, starting node 1, ending node 3. 1